Write cleaner SwiftUI code with MVVM, protocols and dependency injection and test it like a pro. In today's tutorial, this is the app that we'll create. It enables the user to download a JSON payload and to filter through different types of events that are available in their city or location. As you can see, the user can filter by published and by draft. So if the user clicks on draft and swipe, you can see there are two different events, and then if they click on publish and swipe to the right, there are three different events. Also includes like some dummy buttons such as check-in and edit, which isn't functional, but you can implement the functionality in your own time. So the first thing we need to do is to create a new SwiftUI project. So this is the payload we'll be using. As you can see in Postman, this is the endpoint, which is https irasinsights.co.uk/room-events.json. And from this payload, or this JSON payload, we'll be extracting an array of JSON dictionaries. The key values we'll be extracting includes image URL, the cost, location, venue, start time, end time, and the status. As you can see, this payload includes 1, 2, 3, 4, 5 records. So the first file we need to create is our room event file. So create a new Swift file. Name the file room event. Click on create. So for the room event, we need to add our attributes. So we need to type in the following struct room event. And to get our attributes, we can look at our JSON payload again. So the attributes that are needed are these attributes, the ones that I've just highlighted. So the room event also has to implement codable so that we can decode our JSON payload. Also identifiable because each record needs a unique ID. Since we're using identifiable, we need to create a variable called ID that has a UUID, so the ID will be automatically generated to include a unique ID. We need to add the following properties: public let name, string, which can be nil, public let image URL, which is string, that holds the location of the image, public let cost, string, that's the price of the event. Public let location, which is also string, which is optional. Public let venue string. Public let start time string. Public let end time, the time when the event should end, which is string. Public let status, which is string and optional. We also need to define our coding keys as well, which is private. It should be private, spelled incorrectly. Private enum coding keys. Coding key. It should be coding key. Coding key, we just have case name, image URL, cost, location, venue, start time, end time, and status. So what else do we need to do? We need to also add a response class or response object. And the purpose of this class, which is a strut, will enable the JSON to be decoded and serialized within our room event object that will contain an array of room events. So now let's create a new file called response. New Swift file. Response. Strut. Response. Codable. Let record room event, which can also be optional, which is a optional array of room objects. We next need to create our event service. And the purpose of the event service, which is a class, is to call our API and extract the JSON payload. So let's go to a new file. Call the file event service. We also need to define a protocol. The protocol name will be event service protocol. And the purpose of using the protocol is to make the code more testable and more flexibility, especially when mocking objects for your UI tests or unit tests, and also when using dependency injection. So our protocol method will be called fetch event, that will use a sync or sync away and throws an error. Also returns an array of room events. And now we can create our actual class. That's final class event service protocol, private let endpoint, and this is the location where the JSON payload is located, which is https iOS insights.co.uk room events.json. That should be .json, no s at the end. We need to implement our stub since we're using a protocol. So let's just click on the fix button. Line 21, I'll just move it up to or before line or after line 15. That looks a little bit neater. Let's start the following. Guard let URL equals URL string endpoint else. So what we've done there, we've converted the endpoint string to a URL. And if the URL is invalid, it will throw a bad URL error. So URL error dot bad URL. The next thing we need to do is to create the actual URL request and to configure the headers, for example using get, as we're getting data. Bar request equals URL request URL request.http method equals get. It should be method. And now we need to perform the actual network call using the URL session. And we do this within a do block. Let data response equals try await that should be await, not wait, try await, URL session, dot shared, data, for request. Now, since we have performed the network request, we have to check to make sure we have received a valid response from the network. We need to use another guard statement, guard let HTTP response equals response as HTTP URL response, else throw network error dot invalid response. So the network error enums, they do not exist at the moment. So we need to create them in later tutorials. But for now, we just continue to implement the code anyway. So what else do we need to do? So the next thing we need to do is to check the status code, to check to make sure it's between 500 but less than 600. So if it is within that range, that means there's some type of server error. And on the UI, the GUI, such as the content view, that would be displayed to show to the user that some error has happened and they're unable to connect to the server. That's why it's important to show some errors on the application. Throw network error dot server error. That should be, if that looks correct. It looks correct. So the next thing we need to do is to check the status again. The status is between 200 and 300. And if it's not, then we have to throw another error. So we can just copy lines 36 to 38 just to reduce the typing. Copy it and change the error numbers, the error codes. So that will be 200, 300. And instead of using server error, that would be invalid response. So in the event that all of this is successful and the API is able to retrieve the data, the next thing we need to do is to decode that data into our variable or into our response object. So we just type in decoded equals try JSON decoder decode response self from data. So the decoded data will be sent or passed into the response and then sent into the decoded variable. And then we just return our decoded data using decoded.record that includes an array. If it was unable to decode it for whatever reason that is, we just return an empty array, which is nil. And then what we need to do now is to capture any errors that may have happened while trying to decode the data. So let's decoding error as decoding error if case dot key not found, and it should be key not found is equal to decoding error. Throw the network error that will signify to the user that some error has happened. Key not found error. Or if it was another type of error, then we just throw decoding error to the user. And we also need another catch block that will handle any URL errors. Such as, you don't have to implement this, it's just some good practices. You can check to see if there's internet connectivity or not by doing the following. If URL error dot code is equal to not connected to internet, then throw network error dot no internet connection. It should be no internet connection. As you can see, some of the properties or variables we need to create in the next tutorial. And then what else do we need to do now? Oh yeah, we just need an else statement that will throw the URL error. And so in the next tutorial, we'll implement the network error struct. Might be a struct, or it could be a class, or with constant variables. So that's for the next tutorial. Write cleaner SwiftUI code with MVVM protocols and dependency injection and test it like a pro. In today's tutorial, this is the app that we'll create. It enables the user to download a JSON payload and to filter through different types of events that are available in their city or location. As you can see, the user can filter by published and by draft. So if the user clicks on draft and swipe, you can see there are two different events, and then if they click on publish and swipe to the right, there are three different events. Also includes like some dummy buttons such as check-in and edit, which isn't functional, but you can implement the functionality in your own time. So the first thing we need to do is to create a new SwiftUI project. Welcome to iOS Insights, the channel for iOS app development using SwiftUI and Swift. Don't forget to subscribe for more Swift and SwiftUI tutorials. In this tutorial, we will add a few extensions, such as the network extension to enable our error messages to be retrieved from the view model and then displayed onto the content view, so that the user has an understanding of what's happening when they see an error message on the screen. We will also implement other extensions. So the first thing we need to do is to create a new Swift file. We will call this Swift file extension network error. We also need to create a function called toErrorObject that will return an error object. The next thing we need to do is to include our conditions of errors that we can expect to retrieve, such as no internet connectivity error. So just type in switch self case dot no internet connection, and then we return the error object, and then within the error object we have to include the actual error, which is as you're online we could not load the latest events. Check your connection and try again. So that's one of the error messages. And the type of error is offline error. The closing bracket on line 70, that's 17. On line 17, that should be moved to lines 18. The next error we need to validate for or capture is called server error. So we have to do what we just done previously. So we can copy the block from line 16 to line 20. And then for the message, we need to pass in the following into the constructor, which is server error occurred, and the message type or the error type is server. The next error type we need to create is a invalid response error type. So we do this after line 26. And then rename no internet connection to invalid response. And then we pass invalid server response as the message or as a parameter. Invalid server response. The error type will be invalid response. And then the final error is key not found. And this normally happens if you include the wrong key in your codable payload, your codable struct. Or if the key is the incorrect case, for example. So you entered a capital letter, but really it should be lowercase. And then it comes up with key not found. So for the message for key not found, we will enter we could not load the latest event. Check your connection and try again. It's similar to the first error. Please check your connection and try again. You can see it's similar to the first error condition that we created on line 16. But I can always like reword your error messages if you want to. The error type will be error. Just seeing if there's anything else missing. Yeah, I made an error. So the error is for the file type file here, it should be renamed to network error plus, like the symbol plus extension. So it's network error plus extension. The next thing we need to do is to create a enum. The purpose of the enum is to have different conditions that will include our errors, such as no internet connectivity, server error, invalid response, key not found, and then the error types such as case, offline, server, error, invalid response, or unknown error. And then when that's done, it will map to the network plus error extensions file that we created about 10 minutes ago. So let's go ahead and create that new file. Swift file, click on next. As I said, this file will be an enum. We can just call it network error. Click on create. So the enums for each of the errors, that's what we're doing now. Case no internet connection. Case server error. Case invalid response. Case key not found. We create another enum called error type. Case offline. That means the device is offline. Case server. The server encountered an error. Case error. A general error when decoding. Spelled case incorrectly. That should be CASE. Case invalid response. And then the final case is unknown. That's when the error type is unknown or unexpected. So now, what do we need to do? I think we need to go back into the network error plus extensions file, and then let's compile it and see if it compiles or not. It cannot find error object. Let me see. That should be error objects. What else can't it find at the moment? Oh yeah, there's a bracket missing as well, I think. No, that's correct. It's in the correct place. Type network has no member invalid response. What did we call it? Invalid. Let me just copy it from here. Invalid response. We also need to create our error object class or struct, so let's do that now. And then we'll try to recompile. And the purpose of the error object is to enable the object to be stored in one centralized location, which is the error object. Each error object will include an ID. So for the ID, we use identifiable Since we're using identifiable, we also have to generate a unique ID using new ID, and then we capture we store the error within the message property or variable, and also the type of the error type. So now let's recompile and see if it likes that. So it doesn't like the return error object message. That looks correct. Switch. So switch must be exhausted. This switch cell case dot no internet connection. I'll just comment this out. Again. Switch cell. Let me just, like there's an error somewhere. Stop connection. Return error object. I'm missing. Oh, it's a comma. Should be a comma there. It seems like I missed out the commas. So let me try to fix that. Into a comma here. Comma. Try it again. That doesn't like that. Try it again. No internet connection. I think that's been repeated twice. That might be one of the issues. So that should be server error. And the one on line 40, you can delete that one. And include the closing bracket. Yeah, that seems correct now. So now we should be able to compile it. Oh, there's another error, decoding error in scope. So where is that? Decoding error. That's within the event service. So decoding error. Oh, that's what the problem is. I spelled the coding incorrectly, so we should fix that. Compile it again. gets compiled. In the next tutorial, we'll be implementing more extensions. Don't forget to subscribe for more Swift and SwiftUI tutorials. Here's the SwiftUI MVVM app we're building, an events list app that navigates smoothly between screens. The best part, you'll start to understand MVVM in SwiftUI so clearly that you can start adding your own features right away after this video. In this first part, we'll set up the MVVM structure, create our event model, and connect it to SwiftUI view so we can display real data instantly. Let's dive in. Open Xcode, create a brand new SwiftUI project, and we'll start to build the foundation of the entire app series. Welcome to iOS Insights, the channel for iOS app development using SwiftUI and Swift. Don't forget to subscribe for more Swift and SwiftUI tutorials. The first file, or the new file we need to create, is our gradient title style, and the purpose of this file is to enable our location element to be styled. So we need to create a new Swift file. Name the file gradient title style. And then type in the following. Import Swift UI struct gradient title style. View modifier, as we want to attach it to different GUI elements such as the label, content, font, dot system dot size, font size. So this will be the font size element that we will pass in to this method, and also bold. For font size, there should be no colon, should be comma. And also we need to define font size. We need to do that at the top. So that should be var font size CG float. It should be CG float. The next thing we need to do is to apply a gradient foreground style that will transition from yellow to orange. Foreground style which will be a linear gradient. And then we have to select the first overload that includes the colors and start point and the end point. And then we just apply our colors within the array. That includes yellow and orange. And we start the gradient from the top leading and we end on the bottom trailing, which is on the right. And then we need a closing bracket. We also need to add some padding to the top of 10 pixels, 10 points. And also add padding, which is leading, which is 12 pixels to the left. I'll just compile it now. So the next thing we need to do is create another file called view plus extensions. So we create another Swift file, name the file view plus extensions. And then we need to import SwiftUI. So the purpose of the view extension is to create or enable a helper function that will easily apply the gradient title style modifier that we created a few minutes ago. So within your extensions view, type the following: function gradient title style, which will accept font size of CG float and return some view. We need to type in the following: self dot modifier gradient title style. Select the font size overload, and then we pass in the font size into the variable. As a parameter to the gradient title style. And then the next file we need to create is the color plus extension, which is a Swift file. Color plus extension. And we also need to import SwiftUI. We can now create our extension on the color. And the purpose of this extension is to enable us to create the right color ranges using hexadecimal values. So we need to create our initializer, which will accept our string, our hex string. Let hex equals hex dot trim characters in dot white spaces and new underline. And new lines. That will remove any leading and trailing spaces from the string. Let scanner equals scanner string hex. Scanner dot scan string, which will skip the hash sign if it's present. And then we also need a variable RGB that will hold the converted value as an integer. 64. Scanner dot scan hex int 64, passing ampersand RGB. And now we extract the red, green, and blue components. Let R equals double RGB. And then we use two more than signs, which is used for bit shifting. Ampersand 0xFF divided by 255. I think I missed out a bracket after double. There should be another bracket there. I'll just copy lines 25. And the next one should be green, which is 8. And the final one should be B for blue, which is 0xff, and then we call our initializer self.init red, green, and blue. On line 27, that should be lowercase x. So there's a mistake on line 29, so that should be red. Missed out the colon. I'll just compile it. Compiled. So our next extension we need to create is for strings. Really, all of these files should be in a relevant folder. Maybe we can clean that up in the next tutorial. But for now, let's just create our next file, which is for strings. Strings extension, which is a Swift file. Strings plus extension. And we type the following: import SwiftUI extensions string, and the purpose of the strings extension file is to enable the date-time format to be formatted correctly, and also the time format as well, such as AM and PM. Let's import, it should be import formatter, no, it should be formatter. So we have to create a new instance of the date formatter. Import formatter dot date. Oh no, that's incorrect. Forgot to create my function. So we need to create our function first, which is called func to 12-hour time. This function returns a string, and we can move this into our function. I'll just move that down here, and then type in the following: import formatter dot date format. Then we do the date format, which is y, a 4-digit date, 4-digit year, and then the month, the day, hour, minute, second. We also need to type the following: import formatter dot local equals local identifier. It should be identifier. EN UX POSIX. And the purpose of that line is to find the consistence when passing in the local, so it relates to the time on the user's device. And there's a little error with the local, so change it to, why is it showing that incorrectly? Local, type it out again. But that should be .local equals local. Cannot find local in scope. I missed out the E, that's why I spelled it incorrectly. So we need to create another instance of the date formatter class. Let output formatter equals date formatter. And then we have to set the desired format of the time that we want the user to see on the application. So the format will be date format, hour, with a 2-digit minute, and then it will either show AM or PM depending on the time of day. The next thing we need to do is to define AM and PM explicitly by using .am symbols. Equals AM, and then we do the same thing for PM. Cannot find date formatter. Oh, could I miss that a T? So that's correct now. And then the next thing we need to do is to attempt to convert the original string to a date object. If let date equals input formatter input formatter should have an extra T as well. For formatter. So the extra T should be there. So it should be input formatter date from self. And then now we can return the correct date to the user, output formatter string date. And for whatever reason the input string couldn't be passed, we just return the string or the date how it is by using self. Now just compile it again. Next week's tutorial will focus on the network error and also the remote image view. Don't forget to subscribe for more Swift and SwiftUI tutorials. Here's the SwiftUI MVVM app we're building, an events list app that navigates smoothly between screens. The best part, you'll start to understand MVVM in SwiftUI so clearly that you can start adding your own features right away after this video. In this first part, we'll set up the MVVM structure, create our event model, and connect it to SwiftUI views so we can display real data instantly. Let's dive in. Open Xcode, create a brand new SwiftUI project, and we'll start to build the foundation of the entire app series. Welcome to iOS Insights, the channel for iOS app development using SwiftUI and Swift. Don't forget to subscribe for more Swift and SwiftUI tutorials. In this tutorial, we'll be focusing on the remote image view. The purpose of the remote image view is to enable images to be downloaded asynchronously from a remote URL, such as this image here is seen in this picture. So this is the actual view we'll be creating that includes the image. The first thing we need to do is to create a new SwiftUI view. Name the view remote image view. Since we are not using previews, we can delete the preview on line 16 to 18. And then type in the following. So the remote image view needs a URL that contains the location of the image to be displayed on the view. And we also need a placeholder image, which is type image. And the purpose of the placeholder image is to display a placeholder whilst the image is being downloaded, or if loading fails, it will display a placeholder. For example, image cannot be displayed or downloaded. We also need an @state property variable that's called loading or loaded image, which is optional. Missed out var. The next thing we need to do is to create our actual image view within a Z stack. So Z stack if let loaded image. So what that means, if the image has already been loaded, that means we have an image that can be displayed. So it's not nil. Loaded image dot resizable scale to fit. That should be scale to fill. And the purpose of using scale to fill is to fill the space, preserving the aspect ratio. Else, we need to display that the image is being downloaded. This is where we use our placeholder, resizable, scale to fill, on a pair, and then we call the method load image, which we haven't created. We need to create it now. That's the name of the method. The purpose of the method load image is to load the image when the view appears. So when this view appears, the one that we're working on at the moment, the image would be displayed here. So the called load image method that I'll create now, and then the image would be displayed here, if it can be retrieved from the server, or here, an image would be displayed if there's an error. Private func load image guards let URL string equals URL string. Let URL equals URL. And we pass in the URL string. If the URL can be converted, or if the string can be converted into a URL, then that URL string will be assigned to the URL string on line 37. If it cannot be converted, then we just exit the function. If everything went okay, we then enter into a task, and then we perform an asynchronous network request to download the image, which is this image here. Let data underscore. The underscore represents a response, but we're not dealing with a response at the moment. Equals try await URL session dot shared data from URL. So line 45 will perform the network request using the URL session on the provided URL. If let UI image equal to UI image data, so we pass in the data of the image that we captured on line 45 and then convert it into a UI image. And then the loaded image variable will contain a reference of the UI image after we pass it to an image. UI image, UI image. So now we have our image to be displayed within our view, within our Z-stack. We also need to capture any errors that could happen, so we have to use a catch block and then just print it, but really it should be like throwing the error to the main view. So that the error bubbles up. Image load is failed. But if you want to see how to do proper error handling, check out the rest of my videos. Localized description. Now just compile it. Compile. The next file we need to create is our events list view model. The purpose of our events list view model is to display the actual events or to retrieve the actual events from the data layer. It will retrieve events such as the event time, the date, and if it's a payable or free event, and the venue of the event. So now let's create a new file. Which is a Swift file. And then let's call the file event list view model. In later tutorials, we'll also neaten up the file structure and put each of the files into their right folders, such as view, folder, view model, models. But now let's just focus on creating the actual event list view model. Import observation. Import SwiftUI at main actor to ensure that all the UI updates happen on the main thread. At observable. So observable will make the class reactive so that the UI displays the updated information. Final class event list view model. You don't have to use final, it just means that we're not using inheritance, but you don't really have to put final there if you don't want to. Event list view model. So that's the name of our class. Next thing we need to do is to create an array. Our array will hold a list of room events. At the moment, it's empty. Var error object, which is optional. And that will be used to show any errors on the UI. Var success message string private let event service protocol, and that is a service responsible for fetching events using dependency injection. Since we're using dependency injection, we need to pass it in with our init method or initializer. Event service protocol equals event service. Self.event service equals event service. And the protocol, the initializer will also enable mocks to be tested this way when doing testing. We need to create another variable, which is a set var event status or statuses. Which is using these sets. So it's using the set data structure, and then this set will hold a list of event statuses that will not be duplicated, so they'll all be unique. And statuses could include things like upcoming events, completed events. We also need to create tabs for the UI, which is an array of string. An actual tab captions will come from our event statuses. But since the event statuses, since it's a set, we need to convert it into an array, and then we sort it in alphabetical order. We need to create another function that's called filtered events for selected tab. And this will return a room event array. Return events dot filter eventing event dot status lowercase is equal to selected tab dot lowercase. And then the next thing we need to do is create another synchronous method. This method is called load events. Using await, perform, and then we fetch the event using the service events, await self dot event service, fetch events from our data layer, and then the next thing we need to do is to update the tab status based on the loaded events. Self dot update event statuses. That function doesn't exist, so we need to create it. Self dot success message equals nil. Have to clear any existing success messages. So now we need to create that method, which is update event statuses. Self dot event statuses equals set self dot event compact map $0 dot status capitalizes each of the statuses in the array. And then what else do we need? I don't know why line 41 is an error. Await perform. I'll pause the video and see if I can fix it. I know what the problem is now, just forgotten. I thought perform was in a sync and await, but it's not. I have to create the function myself. So yeah, we need to create the function called perform. The purpose of perform is to handle the results of a asynchronous operation and map any errors that the application may have, and then return any of those errors as an error object. And that's the purpose of perform. So let's create that function now. Private func perform. Operation escaping sync throws void. Let's compile it. Do try await. And then you need operation. So the purpose of operation is to clear any previous errors if the operation succeeds. We also need a catch block to handle any network errors. Self.error equals network error dot to error object. Then we create another catch block. Self.error equals error object. And with this error object, we just pass the error such as unexpected error. And then error dot localize description, and the type of error is unknown. The next function we need to create is system for error type, which is symbol for error type. And the purpose of this function is to display a symbol that relates to the error. and we're returning a string because we're just returning the symbol name. So if the error was to do with offline, then we would return the symbol, the system image name for Wi-Fi.slash. Or if the error was to do with server, then we would return an exclamation mark dot triangle if the error was an error, then we just return exclamation mark dot cloud dot fill. If the error was invalid response, then return string would be question mark dot folder. If the error was to do with unknown, then we just return question mark dot diamond. There's a few mistakes. So on line 74, there should be full stop before error, and on line 72, there should be a colon after server. Let's compile it. In next week's tutorial, we'll start to add our event cards, as you can see on the screen here. So you can slide from one event card to the next. And that's for next week's tutorial. Don't forget to subscribe for more Swift and SwiftUI tutorials. Here's the SwiftUI MVVM app. We're building an events list app that navigates smoothly between screens. The best part, you'll start to understand MVVM in SwiftUI so clearly that you can start adding your own features right away after this video. In this first part, we'll set up the MVVM structure, create our event model, and connect it to SwiftUI views so we can display real data instantly. Let's dive in. Open Xcode, create a brand new SwiftUI project, and we'll start to build the foundation of the entire app series. Welcome to iOS Insights, the channel for iOS app development using SwiftUI and Swift. Don't forget to subscribe for more Swift and SwiftUI tutorials. Today we'll focus on the stepper, indicator view and the event card view. The purpose of the stepper indicator view is to enable the user to navigate from different cards or screens as seen here. As you can see, these two dots, if the user swipes any of these two dots, then the event card view will navigate to a different view. And the event card view that we'll be implementing will include the event thumbnail and the date and the time and the location of the event as seen on the screen here, and it also will indicate if the event is free or not. So this is what we will be implementing today. The first thing we need to do is to create a new SwiftUI file. Name the file stepper indicator view. And then type in the following: let total int, and the purpose of that variable is to assign the total number of steps or dots to be displayed. As shown earlier in our version, it just includes 2 dots. We also need another variable which is called current index, and that should be int data type. And the purpose of that variable is to highlight the dot that we're currently on by using the current index. We also need a on-tap closure, and the purpose of the on-tap closure will enable the user to tap the actions of the dots so that the user can navigate from one event to the next and display those information on the screen. We can delete the preview as we're not using it at the moment. Next thing we need to do on lines 19, we need to loop through each of the steps for each less than total ID. So we give each of the elements a unique ID. Index in. And then to create the actual dot, we use the circle shape. And then we fill the circle shape. Index is equal to current index. So we fill the circle shape with a different color based on whether it's a current step or not. Color dot primary, else it should be primary, There's color, secondary, opacity 0.4. The next thing we need to do is we need to set the frame or the size of the dot. So the width of the dot will be 10 pixels and the height will be 10. And to enable the user to have interaction with the dot, we have to use on-tap gesture. So when the user interacts with the on-tap gesture, it will call the on-tap with the index. And that will be returned by the closure. We also need to add a bit of padding, top 8, and also some padding to the bottom 16. And we missed out something, that was my mistake. We need a H stack on lines 20, a spacing of 8, now just compile it, or let me just indent it a bit, do some indentation. It's compiled. So the next thing we need to do is to implement the events card view. So to do that, we need to create another SwiftUI view. Event card view. After lines 10, we need to enter the following: var event, room event. Delete the preview. The purpose of lines 12 is to capture the event data that needs to be displayed on the view. We also need an at state, private var, variable is image loaded, equals to false, and that just tracks to see if the event image has been loaded successfully or not. We can delete line 17. Then add the following: geometry reader, geometry in. We need a Z stack. And now we check to see if the image URL is valid. If let URL string dot event image URL, not URL, string is empty, let URL equals to URL string URL string. On line 21, what we just done a check to see if the image URL is valid. So if the URL is valid, that means we're able to display the URL within our view. So to display the URL within our view, we use the async image, and then we capture the URL. Then we switch the phase. So if it was empty, then we need to display a Z stack. And also display a progress bar or spinner to indicate that something is being retrieved remotely. Color.gray.opacity 0.2. Progress view style circular progress view style, and then we need the tint overloading method for the color. That needs to be primary. On line 23, I spelled phase incorrectly, so that should be PHASE. For the next case statement, if it was a success, then we capture the image. Image.resizable scale to fill. Dot on a pair is image loaded equals true. So we now have the image, so we assign the is image loaded variable to true. In the event we're unable to get the image or to retrieve the synchronous request, then we use the failure statement. And then we also use a fallback image, which hasn't been created as yet. But the purpose of the fallback image is to enable the user to have some image displayed on the screen in the event of an error. So we'll create the fallback image later on. Just add a bit of indentation there. And then we also need unknown. It should be unknown defaults. And the purpose of the unknown default is to handle any unexpected cases. And then we call the fallback image again. To stop Xcode from complaining, let's just create the fallback image now. After line 46. So just type in the following: private var fallback image, some view, vstack, spacer, hstack, spacer, image, system name, photo. So the image system name photo will be the fallback image. Let's make it resizable. Scale to fit. The frame will be 68. Frame width 68 pixels, and the height will be 68 pixels, so it's nice and square. The foreground color, white, opacity 0.6. Spacer, we also need another spacer here. And then for the background, that will be dot gray, dot opacity 0.2. I'll just compile it. The next thing we need to do is after lines 41, we need to add dot frame. width, geometry, size dot width minus 32, height, geometry, size dot width times by 1.2, and then we need to add a clip and a corner radius 24. And we also need to reuse this, so I just copy and paste it. Really, it should be within a function or a reusable view. And so we need an else statement here. If no image URL, then we need to show the fallback image again. And then just paste that there. The next thing we need to do is to add an overlay gradient to the bottom of the card. To do that, we need to implement it after lines 49. So if is image loaded or event.image URL is empty, then we add our linear gradient that will include the following. So the overload that we need is first one, which is colors, and then we just pass in our gradient. That is incorrect. It's the second overload that we need. That's the one. So we pass in our gradient with our array of colors. So the colors that we're passing in includes dot clear and also dot black, opacity, .85. Start point will be dot top and the end point will be dot bottom. We also need to add a corner radius of 24 and the frame. Width.geometry, It's not picking that up. So the corner radius, that's right, 24. Where's the geometry? I'll just try it again. So that should be frame width, geometry. I just picked it up now. I must have spelled it correctly the first time. Minus 32. And height, geometry, size. Width times by 1.2. And then the next thing we need to do is to create another V-stack. Alignment.leading, spacing 4. And then within the V-stack we show the event name. If the event name doesn't exist, we just display or include blanks. And we also show the event venue. And then we use a gradient title style with a font size of 24, not 24, 14. We also need to show the location of the event.location, gradient title style 28, and a spacer. We also need to show other information such as the date of the event, if it's happening today or not, and if the event is free or chargeable. Should be hstack, spacing 50, and we have a vstack, alignment, leading, spacing 4. And then for our label, we just display today. For the system image, we just use calendar. Here's the SwiftUI MVVM app we're building, an events list app that navigates smoothly between screens. The best part, you'll start to understand MVVM in SwiftUI so clearly that you can start adding your own features right away after this video. In this first part, we'll set up the MVVM structure, create our event model and connect it to SwiftUI view so we can display real data instantly. Let's dive in. Open Xcode, create a brand new SwiftUI project, and we'll start to build the foundation of the entire app series. Welcome to iOS Insights, the channel for iOS app development using SwiftUI and Swift. Don't forget to subscribe for more Swift and SwiftUI tutorials. In this part of the tutorial, we will continue with our events card view. The next thing we need to do is to add a VStack after line 71. And the purpose of this VStack will enable the user to see the time and the date of the event, which will also be within a label. They type in VStack, alignment, leading, that should be dot leading, spacing 2 pixels, next thing we do is to create the label that will include the start and the end time of the event. Event dot start time, if it's nil, if it doesn't include a value, you just put blank there, and then we convert the time to 12-hour clock and not 24. So we need to use on line 74, there should be 2 brackets. Let's do that again. 2 bracket there. Let me type that again. I think there's an issue with the text element. So that should be label, to type it again. Title. Should be capital L. Text. And then we type event dot start time. And then missed out the bracket again, so we need another bracket after the text, after the backslash. to 12-hour time. So it converts the time to 12 hours. And it does the same thing with the event end time. Which is also converted to 12 hours. Need a bracket, another bracket there to 12 hours. Missing arguments. What is that? Missing argument for parameter icon in core. Yeah, we need to add our icon. Let's do that afterwards. But there's something else we need to do, which is to add the line limit. Which is 1. So it won't be multi-lined. Also needs dot minimum scale factor, which is 0.8. And then we will add our icon for our image, which will be icon image system name dot clock. So what we're trying to create is this. I think there's a screenshot here somewhere. We're trying to create this layout that shows the time, which includes the start time and the end time of the event. The next thing we need to do is to add another label, and the purpose of this label will show if the event is free or paid event. So we can just copy what we've done previously. Just copy it and then paste it on the lines 82. I'll just compile it to make sure there's no errors. And then instead of the title element of the label having start time and end time, it will have event cost to signify if it's a free or paid event. We just type in the following text. event.cost, capitalize. If there's no cost, that means it's a free event, so we type free there. Else, it would be a paid event. For the system image, we just use exclamation mark, dot circle, and then we need to add a foreground color to our, what do we need to add it to? We need to add it to our title element within our label, so we need to set the foreground color to yellow. So it should look like this, as you can see here within the image. So today will be yellow, and the start and end start and end time will be yellow, and if it's a paid or free event, it will be yellow as well, including the system image names, or the system images, they'll be yellow also. So to do that, we need to do that after lines, I think it's after line 94. Or after line 95. So just type in font sub headline dot foreground color dot yellow, opacity 0.9. We also need to create a horizontal divider as seen here in this image. You can see there's a faint line where it includes two buttons, so we have to create that faint line, which is a divider. And then we create the buttons afterwards. So to create that shape or that line, we have to use rectangle. We fill the rectangle with a color, which is white dot opacity 0.2. The frame height of the line will be 1 pixel, and also the frame max width will be infinity, and the alignment will be dot leading. We also need to add some padding, which is horizontal -16, and then that should be -16, so the 16 should be close to the minus symbol. And then we also need to create our buttons. So our buttons will be within our H stack that will include 12 pixels of spacing between each element, between each of the buttons. The button caption for the first button anyway will be check-in, So that's the first button. As I said before at the beginning of the first tutorial a few weeks ago, the actual buttons, they don't do anything, but it just shows you how to lay out a card that includes buttons. So font weight should be medium. It should be font weight, yeah, medium. And then padding, that would be dot vertical 10. Yeah, that's right. And then frame, it should be max width infinity. It should be infinity. And the background is ultra thin material. Foreground color white. And the corner radius is 12. We also need to create the edit buttons. So what we'll do here, we'll just copy and paste what we've done for the first button. And then paste the button anywhere after lines 112. Name the button caption edit. I think we can leave everything else how it is. Vertical 10, infinity, ultra thin material, white and 12. So what we need to do next is add some padding for the buttons. And then we also need to add a frame as well, which is after line 124. Frame width geometry size dot width minus 32, and then height geometry dot size dot width times 1.2. And then the next thing we need to do is to set the size of the cards using the geometry reader dimensions. Similar to what we just done previously above, so I'll just copy that line and then paste it anywhere after lines 129. So that should be width geometry dot size dot width. We don't need a minus or 32 there, and then we just need height geometry dot size dot width times by 1.2. And then yeah, I think that's that for that view. Let me just compile it to see if it's okay. And then what else do we need to do? Also, please let me know which tutorial would you like to see next. You can drop your comments on the channel or email me directly. Here's the SwiftUI MVVM app we're building, an events list app that navigates smoothly between screens. The best part, you'll start to understand MVVM and SwiftUI so clearly that you can start adding your own features right away after this video. In this first part, we'll set up the MVVM structure, create our event model and connect it to SwiftUI view so we can display real data instantly. Let's dive in. Open Xcode, create a brand new SwiftUI project, and we'll start to build the foundation of the entire app series. Welcome to iOS Insights, the channel for iOS app development using SwiftUI and Swift. Don't forget to subscribe for more Swift and SwiftUI tutorials. In this tutorial, we will implement the Events Row View. The purpose of the Events Row View is to display the event information in a vertical row format, such as we'll be displaying the times of the event, the start time, the end time, and if the event is today. If it's not, then we will display an actual date, and we also display if the event is free or payable. So this is the feature we'll be creating in today's tutorial. The first thing we need to do is to create a new SwiftUI view. So just create a new Swift file instead and name the file Event Row View. Import SwiftUI, and then we create our struct, which is our view, Event Row View, which will implement or inherit from view. Let event room event. The room event is the object that contains all of the information for the rooms, or all of the data for the rooms. Var body view, and then we create a VStack. The VStack will have an alignment of leading. Each element within the VStack will be spaced by 8 pixels. The next thing we need to do is to check to see if an event has a valid URL. So we have to use safe unwrapping image URL. So if the image URL is an empty, that means we have a valid URL. We next need to display the remote image. So to do that, we need to call our remote image our remote image view that we created in a previous tutorial, and then we pass in our image URL, and then for the placeholder we just pass in a system name, which is the photo. So that photo will act as a placeholder. We also set the frame height for the image, which will be 150 pixels, and we also click the image, add a corner radius to make the corners curvy and not sharp. The next thing we need to do is to display each of our event attributes, such as the venue. If the venue does not exist, then we just include like safe unwrapping. And then we just style it with our font.headline, add a foreground color, which is secondary. And then we need to display the location of the event. For example, that could be Manhattan. This is the location. So I'll just copy what we just done previously, and then I'll just paste it. Rename it to location. The foreground color will stay the same, which is secondary, but we don't need the headline. The next thing we need to add is the start time. So we just call the attribute of the event start time. Instead of having unknown, on line 31, that should be unknown location. Event start time, that should be NA if it's not available. And for the font, that should be caption. Should be caption. We also need to display the end time of the event, so that will be NA again if the end time doesn't exist, which means not applicable. And the caption will be, the font will be caption, it should be end time. We also need to display the cost of the event. If there's any cost, it could be free. So that would be cost. That would be event cost capitalized If the cost does not exist, just type in NA for the default. And then we need to include a question mark to unwrap cost. The caption will be, the font will be font.caption, and then we need to add a vertical padding around the entire view. Padding.vertical 8. I'll just compile it. The next thing we need to do is to open our content view so that we can call the view model and display the UI elements on the view to enable the user to interact with the application. So the first thing we need to do is use @main actor, and this will ensure that all updates to the view model and the UI happens on the main thread. We now need to create an instance of our view model. Really, we should be passing this in as a dependency, but I've covered things like that in previous tutorials, so that should really be within a dependency injection initializer method. @state private bar selected tab string, which is upcoming, and the purpose of that line 14, is to track which tab is currently selected, such as upcoming, completed. @state private var current event index int equals 0, and that includes the index of the currently visible event within the tab view. We also need to use @environment so that we can access and change the color schemes within light and dark mode. Just see if the preview will work. I don't know, because as I keep saying, the MacBook is so slow. On lines 21, we need to change this to the Z stack. And then we need to type the following color. It should be color app background ignore safe area. And that will set the background color from the assets catalog and ignore the safe area. bstack alignment dot leading spacing 20, and then we create a HStack, and this will be the top row that includes the user and the icons. Image, system name, person.circle, font, title, foreground color, color, hex, so the hexadecimal color will be 80D1F5. We can delete the text between lines 33 and 36. That includes the image and hello world. We can delete that. We also need to add a spacer, add another system image name, which will be plus circle.fill, font.title, foreground color, which will be another hexadecimal value, for the color. And we can just copy the color that we created previously. And then we need to include our foreground color for our HStack. That will be white. Next thing we need to do is set a title for the actual application, which will be SRM, Event Helper. Let's just add a text element. SRM, Event Helper. Font dot system size 28. Weight will be weight, so that will be dot bold. There's an error somewhere. we shouldn't have the closing bracket after 28. So let's stop both these two closing brackets. As you can see, we've nearly done this part. Foreground color dot primary The next thing we need to do is create the tag bar for filtering events by the status, which is seen here. So it filters the events by draft or publish, and depending on which card you're looking on, it will have different filters that you can filter the events on. So this is what we'll create now. HStack spacing 0 for each new model dot tabs indices ID indexing Is that correct? Indices, remodel tabs. Let me just type in the rest and see if it will be okay after that. Remodel tab. So we get the tab index of that remodel. Add in the tab index for the different types of filters that we're going to be using. Yeah, I don't know what's wrong with that. So the view model, is it to do with tabs? Into the view model. Let's see, so it's the view model, the tabs. Event this view model. And that seems correct. Return array event status dot sorted. Event status. private set var event statuses set is correct. Maybe we can fix that issue later. So let's just try and fix it later then. So the next thing we need to do is to create our button. Our button has an action. Our button also needs a caption within the text element, so it needs a string to be displayed that will resemble the filter options for the tabs. Font dot sub headline font weight dot semi bold dot foreground color selected tab is equal to tab. So if selected tab is equal to tab, then the foreground color will be black, else it gets the color using dark and light mode. Color.white.opacity 0.5 grey. Oh, that was the problem. It was a spelling mistake. There shouldn't be, really there should be an S after tabs. It should be tabs and not tab. So let me rename it. That's okay now. Next thing we need to do is to add a frame, max width, infinity, padding, vertical 8, got background, which is similar, a little bit similar to what we just done. So that will be selected tab is equal to tab. Then the color will be white, else the color will be clear. Add a corner radius of 10. The next thing we need to do is to add the divider between the tabs. There's something else that we didn't do. On line 15, we have to call or assign tab to the selected tab within the click event. Selected tab is equal to tab. And then we need to add our divider between the tabs. If index is equal to 1, then we just create or add a divider and specify the frame of the divider. So the width will be 1 and the height will be 20. The background color will be white. Opacity will be 0.2. But because we're in light mode anyway, we won't really see it. See the effect, we'd have to be in dark mode. So that should be background. Okay, let me qualify it with color, see if that helps. Just take the preview updates. So what happened there? Build cancelled. Let me just build it normally. As you can see, the preview doesn't always work. I'll try it again. In the next tutorial, we will complete our content view, and then after that, we will start to implement units and UI tests. Here's the SwiftUI MVVM app we're building, an events list app that navigates smoothly between screens. The best part, you'll start to understand MVVM in SwiftUI so clearly that you can start adding your own features right away after this video. In this first part, we'll set up the MVVM structure, create our event model, and connect it to SwiftUI view so we can display real data instantly. Let's dive in. Open Xcode, create a brand new SwiftUI project, and we'll start to build the foundation of the entire app series. Welcome to iOS Insights, the channel for iOS app development using SwiftUI and Swift. Don't forget to subscribe for more Swift and SwiftUI tutorials. In this part of the tutorial, we will implement the feature that will get the events based on the selected tab events, such as seen here. So if I click on like draft, then it gets all the events that relates to draft. If I click on publish, then it gets all of the published events. The first thing we need to do is to create our divider, so we need to Add a frame. The height is 40. Background color black. Opacity 0.2. Corner radius is 10. And now we get our list of events, filtered events. So this will get the events based on the selected tab. View model dot filtered events for selected tab. If not filtered event, is empty. Then we display our VStack, spacing 12, tab view, selection, current event index, for each filtered events dot indices ID. We give each of the filtered events records a unique ID, self indexing, and then we display the event card, filtered events. By using our filtered events array, we pass the record to the events card, and then we add horizontal padding, the tag index, for the tab style we use tab view, page, index, display, display mode, never, which will include these two little dots to enable navigation also. So you can navigate using the two little dots, so you can swipe from left to right. Frame, height, UI screen, main, bounds, dot width, timed by 1.2 plus 20. I made a mistake. This is the section for creating the dots so that we can navigate from screen to screen. So this is the section that we're implementing at the moment. So to do that, we have to use our stepper indicator view, and then we pass in the following parameters, which includes filtered events, dot count, the amount of events we have in our array, and the current index, the current event index, and within our closure we need to add tap index in with animation, and then that will change the current event index to be the tap index so that the screen navigates to the right record, also that the right record is displayed on the correct screen. We also need to include a spacer see if the preview works. Yeah, see, the preview doesn't always work. That's what we need to do. In the event that something goes wrong, we need to show an error to the user, so we have to create some UI to show that to the user. So we do that after line 100. Else if let error equals view model error b stack that should be spacing 12 image system should be system name, which will be model.symbol for error type, and this will get the correct system image for the error. Dot resizable scale to fit frame height 100 foreground color style which will be the hex value, the 7BA3B1, and then we do a similar thing for the actual error message. Because previously we just created the code to display the symbol for the error, but this will display the actual error message. String, it should be string. Describing error type. Capitalized. A few new lines. And then we just display our error message. Font.system size 20. Foreground color, similar to what we've done previously in this line. So I just copy and paste it. And then the actual text needs to be multi-lined, aligned, or multi-text aligned and centered. And the reason why it needs to be multi-lined because the error message could be very long. The frame max width is infinity. Alignment, center, and padding. There should be a dot before frame on line 116. So what else do we need now? We also need to create a retry button to enable the user to retry the events in case or in the event of any errors that have happened. They can try to retrieve the information from the web service, which is the API. So we need to create a button. Button has an action. Need a task. Current event index is equal to 0. Await view model dot load events if not view model event statuses is empty. Then we use selected tab, and for each of the tabs within the array, we have to convert it to an actual array view, because at the moment the tabs are in a set, so it doesn't include any duplicate tabs, event statuses, and then we sort it by first. or for whatever reason, if it couldn't be retrieved, we just assign our default, which is upcoming. Then on lines 128, we need to include the text element for the button, that we have the caption, includes retry, so that the user knows that they can retry the functionality to call the web service from the view model. And it should be semi-bold with the font weight. Frame width 83, and the height 50. Background color, so that should be hex. To CA, or 2C4 A57. On lines 131, we don't need a colon there. Also, the foreground color should be color hex 9A C5 DC. Corner radius 12. And the frame, it should be max width infinity alignment center. We just add some padding. And a spacer. We'll just save it. And then what else do we need? We also need to reset the current index when the user switches on different tabs. So we need an onChange event, onChange of selected tab. I think there's an issue with formatting, but let's fix that afterwards. So that should be current index, current event, index is equal to 0. I think there's definitely a formatting issue. There was an issue with the view, with the content view, so I had to fix it offline. So this is the complete implementation of the content view. And now you can also run the application in the simulator. As you can see, you can navigate to different screens, click on different events to see which events are published. In next week's tutorial, we'll start to implement the UI in unit testing.